In this video, I'm going to show you how to use some program development tools under Linux. In this directory metric temp, we have one source file, main.c, and what's inside of it is, let's take a look. We've got a function f to c, which does the conversion from Fahrenheit to centigrade. And we have a main, which takes its first parameter and converts it to a floating point number, and then prints out that temperature both in Fahrenheit and centigrade. And notice at every step, from checking we have enough parameters to converting the parameters to floating point numbers, if there's an error, we go to this usage message that tells you how to use it. And so to compile this one file program, get a shell, and we just use the compiler called cc for C compiler. Tell the output file, let's say it's f to c, and then the source file is main.c. I deliberately gave it a bad name so that we can talk a little bit about that later. So there, compiled out errors. I can run f to c. Let's say with 32 as its parameter. Yeah, 32c is freezing. 32f is freezing. That's 0c. And if I run it without any parameters or with an unconvertible parameter, it tells you how to use it. So, in any case, this program works correctly, and now comes the interesting part of the video. In a small program like this, it's really okay just to put all your code in one file, and that's traditionally what people do. But let's imagine this is a much bigger program, and we're going to need lots of metric conversions, and this little main is just our test code. So what we're going to do is take f to c, that function, put it into a file containing our metric conversions called metricconv.c. Let's also rename main.c to be test.c because it's just test code. Finally, let's delete away the executable file f to c. Okay, and now it's time to compile them. Now when you have multiple source files, you don't compile them all at once. You compile each of them separately into what's called object files. So we'll run cc minus c means compile this file to an object file. It's a binary file, just contains the code for this file's functions. Let's say metricconv.c, and look at the current directory. Now we have a metricconv.o file. It will also compile cc minus c of test.c, and notice that our compiler's not happy because we're calling f to c, but the compiler doesn't know the type. See, unlike Java, C only looks at one file at a time, and so it has, since the body of the function f to c doesn't occur in this file, the compiler has no idea what its type is. So let's create what's called a forward declaration. We'll say that there is a function. We're declaring that there is a function of type float, f to c, whose first parameters of type float. And with this, and when the compiler sees this, it knows now the types of the parameters and the return value, and then when we compile it, it won't complain. So then we can link together cc minus o, we'll say f to c dash test, what we call the program, and we'll reference test.o, and what's the other one? metricconv.o. And we'll try running it, /f to c test of, let's say, 68, should be 20 degrees C. Oh, 60, so it's 15.5. So if you have to make a program for multiple source files. Compiling it gets you a little nuisance because you have to compile each source file into an object file and link them together. But there's this wonderful program called Make that makes it easier. The idea is we create a database of what executables depend on what source files. We're going to create a file called makefile, and in here we're going to tell it we're building a program called, let's say, F2C test, and it's dependent on metric conf.o and test.o, and if those files are available, but I hit tab and highlight it in purple because tabs are necessary here. Then we should run the command cc -o f2c test, and then we just have to repeat the list of O files it's dependent on. And what's wonderful is that Make already knows how to make an O file from a C file. So I'll get back to my shell and we'll run make. It's going to look for a file called makefile. And look what it did. It compiled each of the C files to an O file and then linked them together. And now we have an executable. A feature of make is that it will only recompile files that are needed. It just checks the dates of all the files. For example, make knows that from this make file that F2C test is dependent on metricconf.o and test.o, and make already knows that O files can be generated from C files, so it checks the dates of all the modification dates of everything. It notices the O files are newer than the C files, and the executable is newer than the O files, so it doesn't have to do anything here. I'll type make, and it says everything's up to date. And now I'll modify one of the source files, let's say metricconf, and add a comment in here. And I type make again. Notice it recompiles metricconf.c, but doesn't bother recompiling test.c because its O file, because its C file, source file hasn't changed. Its O file is newer. What if we made a change to the include file? They both depend on. Let's to metricconf.h, and I'll just put a new line at the top. I'll type make. Notice it says it's up to date. Why is that? Let's think about what make knows. From the make file, make knows that it needs to have a metricconf.o and a test.o, and it just looked around for source files and found a .c, but has no idea what include files they reference. But we could indicate that metricconf.o is dependent on metricconf.h and metricconf.c. Similarly, for test.o, it depends upon metricconf.h and test.c. And now when I run make, it does everything it's supposed to. The last thing I want to show you is how to clean things up. Notice our directory contains the O files as well as the executable. I might want to clean up all of the non-source files. So it's going to be the .o file and the executable F2C test. And we can actually trick make into doing that. Go back into our make file. So by default, it makes the thing on the top of the file. We're going to say that there is a bogus file called clean. That in order to make clean, we're going to have to remove all the O files and F2C test. So if make ever wanted to make clean, it'll run that command. It has no idea otherwise how to make clean, but that command should do. You will remove all the files we need to clean things up. Let's see what happens. So to run make, where you want to make a particular output file, clean. Of course, clean doesn't really exist, but it's going to look for it, see it's up there, and run this program hoping to make it. And look what it did. It cleaned things up. It deleted all the extra files. So let's take a look at the directory. And now we have just our source files. So I'm going to suggest that every make file you make should by default compile the project, and then also include a production for clean, which cleans things up.